Please open in your learning workbook to page 100 and read along as we learn together. Understand the meaning of a raised to the m over n power, positive rational exponents. Definition of a to the m over n power. If m and n are positive integers greater than 1, with m over n in simplest form, then a to the m over n equals the nth root of the exponential expression a to the m, which also equals the nth root of a all raised to the m power, as long as the nth root of a is a real number. You might notice in the blue box the important sentence, the denominator of the fractional exponent is the index of the radical. This was true in our previous video and remains true for this learning objective as well. Let's look at several examples. Use radical notation to write the expression. Simplify if possible. We're given 16/9 raised to the 3/2 power. Okay, the first thing that we want to do is we want to compare what they gave us to the left part of this double equality statement. The base, a, is the fraction 16/9. The exponent is a fraction. The numerator, m, is 3, and the denominator, n, is 2. Let's rewrite this in two different ways using the definition we learned. The denominator of the fractional exponent tells us the index of the radical. So this is going to turn into a second root, also known as a square root. The base, a, is the fraction 16/9, and m, which is the numerator of your fractional exponent, is 3. Now normally we would not write the 2 for a square root. For this problem, and as an academic exercise, I'm leaving it there for clarity, but it would normally be removed. The other way that we could write this would be to say, parentheses, the nth root of a, well for this problem n is 2, so the square root of a, the base, which is 16/9, all raised to the m power, which is the numerator of the rational exponent, which in this case is 3. All right, so both of these are equivalent to what we started with. However, one of them will be easier to work with than the other. Let's see if we can figure out which one is easier to work with. If I were to simplify each one of these things, I would follow order of operations. So first of all, this is a square root, and I'm simply going to drop the 2 now that we're moving on to simplifying. 16/9 cubed. Well, I can do that in my side workspace. 16/9 cubed is the same thing as 16/9 times another 16/9 times another 16/9. Let's see if we can work that out together. 16 times 16 times 16 is 4,096. And 9 times 9 times 9 is 729. So, if we decide to use this part of our formula, we'd have to find the square root of this fraction with some rather large numbers. Let's turn our attention to this one. Okay, this one asks us to find the square root of 16/9. that means we need to find some number that when we multiply it by itself gives us 16 over 9. Well, that's pretty easy to do. These have to be the same number, and since the result is a fraction, that gives me some indication that each number inside the boxes should be a fraction. What number times itself makes 16? That would be 4. What number times itself makes 9? That would be 3. So from this we learn that the square root of 16 ninths must be 4/3. Of course, I still have the parentheses and the exponent of 3 as part of my problem. Now, let's look at these two possibilities. Which one of these appears to be easier to work with? I hope you come to the same conclusion I do, which is that this one would be easier to work with. The numbers are smaller. Generally speaking, this part of our doubled equality is more useful most of the time. Okay, so let's continue to work with this one since it seems easier. 4/3 cubed. Well, that's just 4/3 times 4/3 times 4/3. 4 times 4 times 4 is 64. 3 times 3 times 3 is 27. So we get the final answer, 64/27. Let's try another one. Use radical notation to write the expression. Simplify if possible. Use your calculator to check your answer. Okay, for this problem we have the base, -81, being raised to the exponent of 3/4. Okay, let's rewrite this. A, the base, is -81 in parentheses. M, the exponent numerator, is 3. And n, the exponent denominator, is 4. So let's rewrite this. This will be the 4th root of -81 cubed, which could also be rewritten as the 4th root of -81, all in parentheses, cubed. Okay, so we learned our lesson from our previous example that this is most likely the easiest way to solve our problem. So let's start here. The first thing we need to figure out is, what's the 4th root of -81? In other words, what real number times itself 4 times gives the result -81? There is no such real number. Imagine, if you will, that you tried to put the same number in each one of these boxes. That number could be positive or negative. Let's say you put positive. What's a positive times a positive times a positive times a positive going to give you? A positive, not this. What is 4 negatives going to give you? Well, let's multiply them as we go. A negative times a negative is a positive, times a 3rd negative makes it negative, times a 4th negative makes it positive. In other words, an even number of negatives creates a positive. So, there is no real number that I can put in all 4 of these boxes that makes this statement true. From this, we conclude that the 4th root of -81 is not a real number, and therefore, we can stop immediately and conclude that our final answer is not a real number. Okay, let's do one last one. Use radical notation to write the expression. Simplify if possible. Assume that all variables represent positive real numbers. Okay, so the base, a, is 3x in parentheses, m is 3, n is 5. Let's rewrite. We get the fifth root of 3x in parentheses to the third power, or we get the fifth root of 3x all raised to the third power. Okay, let's see if we can simplify. With this, we can simplify by removing these parentheses. 3x cubed is the same thing as a 3x times another 3x times another 3x. 3 times 3 times 3 is 27. X times x is x squared, times a third x makes it x cubed. So this simplifies to the fifth root of 27x cubed. This cannot be simplified further. Therefore, there are two equivalent correct answers to this problem. They are both considered simplified, and they are both considered correct.